Called molarity. Molarity is the number of moles of solute in 1 liter of solution. To review, what's this solute again? Anything that be broken down or to dissolve. And what's the other part? Solvent. Alright, so we have moles of solute, liter of solution, and so it's a very, very simple formula. Molarity is equal to the amount of solute measured in moles divided by the volume of the solution measured in liters. So whereas last test we had the gas laws and you had all these different variables, all these different units. It could be atmospheres or kilopascals, or it could be milliliters or cc's, or it could be Kelvin, it could be Celsius. This molarity has to be moles and it has to be liters. So in a way it sort of makes it a little easier because you know where you have to go. Everything has to be converted to moles. Everything has to be converted into liters. So you got molarity, which basically is the concentration, the strength of your solution. And the way you find that is the amount and this, the volume. Now, is there anything in my lab that measures moles? What do I measure in my lab? Grams. Can you convert grams to moles? Yeah. So you probably got a pretty good idea how this is going to work, but it's not that bad. If you don't have a periodic table, go and get that out. You will need that today. You don't have one. When all it's over with, I'll get you one. You just look on with someone until the lecture is over. So if you got a periodic table, go ahead and get it out. All right, if a chemist has a 3.5 liters of solution that contains 90 grams of sodium chloride, what is the molarity of that solution? All right, this is a very straightforward one. In that, much like last test, get everything labeled, figure out what you're looking for, and that'll help you along your way. All right, so 3.50 liters. You only have 3 variables. Going back over here, you only have 3 variables. You got moles, you got liters, and you got molarity. So, you have a 3.50 liters, so that's a measurement of volume. So that'll be your L, and that's a really big pen. All right, 90.0 grams of sodium chloride. Is that moles, molarity, or liters? No. But what can I use that to? All right, I can take the, so moles would equal 90.0 grams of sodium chloride. And then I've got sodium chloride on the outside. Where does it go on the inside? The bottom. So got grams of sodium chloride going to moles of sodium chloride. All right, what goes where? If I got moles and grams together, there's always something that's the same. 1 mole. Okay. How do I get this number? Periodic table. You find, what's that called? Atomic mass or the molar mass. So you look at it and you say, all right, how many sodiums do I have here? 1. So 1 sodium. Sodium weighs 23. I got 23. And then I got 1 chlorine, which is 35. So 23 plus 35 equals 55. I'm just glad y'all caught it. Not everyone's caught stuff like that. Alright, if it's on the bottom, what do I do? 90 divided by 58. 90 divided by 58. Alright, it goes back to my problem. How many's here? 3. So I'm going to have 1.55 moles of sodium chloride. Now just think, back, October, that would have been the problem for the day. Find molar mass, but now it's just a step. How far we've come. Now, molarity, that's the big M, equals what? Alright, we're going to shorten it up. Moles over liters. That's what molarity is equal to. Equals moles over liters. Do I have moles? Do I got liters? Yes. 1.55 moles divided by 3.50 liters. 1.55 divided by 3.50. How many 6/8 should I have? 3. So it should be 0.443, and the unit is a big M. 0.443 molar or 0.443 molarity, depending on who you're talking to. So it's a 0.443 molar solution of sodium chloride. And that's just the strength of it. Not that strong. Any problems so far? So while you're writing that down, why would you want different strengths of a solution? Why would I want to dilute a solution down? Okay. Why would that be a bad thing? Okay. What about me as a teacher? Why would I want to dilute it down? Told you the first day, everything I show you looks like what? Water. Because the majority of things that I give you are like 0.02, 0.03 molar. Very, very weak. In case it gets on your hands, you don't burn your hands. It gets on your clothes. You won't mess them up too badly. If I gave you the real stuff, the strong stuff, it looks like it's a moonshine bottle that I'm always going to bring it out, you don't mess with that. That stuff's like thick, and that can cause some major problems. Also, there is the financial concerns. I can use about a pipette for one lab and make a couple of liters versus using an entire jar every time we do a lab. So there's a financial concern, there's a safety concern, and then sometimes those strong ones A strong solution may get so strong that it actually destroys my other reactant. So the reaction won't even happen because one is too acidic or too basic and destroys the other one. We'll get into that in the next unit when we talk about acids and bases. All right, if you have 0.8 liters of a 0.5 molar HCl solution, how many moles of HCl does solution contain? First step, you need to label what everything is. All right, 0.8 is going to be your what? Liters. 0.5 molar is going to be your molarity. Not, okay, there's where you get, don't say moles. It's the molarity. It's the big M. So your big M is equal to 0.5. Because there will be some of you, that's going to be your hiccup, is that you want to label the big M as a little m. All right, it says how many moles of HCl does the solution contain? Well, we got big M equals moles over liters. Okay. I'm looking for which one? Moles. So how am I going to rearrange that to solve for moles? Multiply. Okay. So moles will equal M times L. Do I got M? Do I got L? Pretty simple. 0.5 times 0.8, 0.4. 0.5 times 0.8 equals 0.4. 0.4 what? Moles. Okay, moles of HCl. In the immortal words of Charles Miller, simple, simple, simple. Any questions so far? Sure. Right here. That's it. Like this question. I especially like it for this class because y'all been having issues with some things not dealing with chemistry, dealing with English and sentence structure. You will need 23.4 grams of potassium chromate. All you have on hand is 5 liters of a 6 molarity potassium chromate. That should be how. How many liters of this solution will be needed to give you 23.4 grams of potassium chromate? So this is basically one of those, if you can do this one, you can do any of them. It's about as hard as they get. This one's good because it gives you extra information you don't need. You got several steps to get your answer, and the question is sort of hidden within the question. Okay, first off, let's be clear. What is this problem asking you to find? Liters. How many liters? Now here's the thing a lot of you will do, is you wouldn't look at that and you would say, okay, there's grams, there's liters, there's molarity. What am I looking for? That's just telling you that I've got 5 liters in my cabinet. I got that much. If I need more than 5 liters, I can't do the experiment. Okay, so out of that 5 liters, how many liters do I need? Okay, so let's go ahead and do it this way. Molarity is equal to moles divided by liters. If I'm looking for liters, I need to rearrange this formula for liters. So liters would be equal to what? Alright, here's something that I picked up because I had the same problem. As good at math as I am, which I'll admit I'm decent at it, this always confused me when I was at y'all's level. But numbers didn't confuse me. Is this true? Is that true? Is that the same setup as this? Yes. So, and when in doubt, 3 equals 6 divided by 2. Which one am I looking for? 3/6 of the 2. 2. So, how do I rearrange 3 and 6 to get 2? 6 divided by 3. So, moles divided by molarity gives me the correct one. Simple, simple, simple. If I still taught physics, that would come in handy so much. Now, do I have molarity? Yes. Molarity is equal to what? 6.0 molar. Do I have moles? No. But what do I have? Grams. Moles equals 23.4 grams of what? Potassium chromate. Alright, I will pat you on the back. This class does very well with converting this to a formula. Okay, so what's potassium? Okay. Chromate. CrO4. And then we got the charges. Charge of potassium is, that was a weak one, 1. Chromate is -2. So that means, there we go, potassium chromate. Ta-da! Still doing chemistry. I got grams potassium chromate. I've got moles of potassium chromate. One goes here. What I got to do here? What's that called? The molar mass. So look, I've got how many potassiums? 2. 2K times 39. And then I got 1 chromium times 52. And then I've got 4 oxygens times 16. And get those numbers and add them all together. So, go ahead, give me the molar mass. $78, 2. So what's the answer? 194. So on the bottom, so do what with it? divided. How many sig figs should I have? The crazy thing is, because this problem is 1. Okay? It's a very badly written problem. So that's going to be 0.1 moles of K2CrO4. Was that what I was looking for? No. That was just to get me over here to moles. So moles is equal to 0.1 K2CrO4. So I'm going to plug that into this formula. 0.1 divided by 6.0. All right, let's look at this. The calculator gives me 0.016667, all that. How many sig figs should I have? 1. So I'm going to round right here. So that rounds to what? 0.02. Where should the decimal be? On the 2. So it's going to be 2 times 10 to the negative 2. And what unit am I in right here? Liters. So it's a lot like I would do in the lab here. So do I have enough? Yes, got plenty. That's just a couple of milliliters. Now I'm dealing with there. Or not even a milliliter. So, if you can do that one, you can do any of them. Just remember, if you don't have moles, you need to get from grams to moles. We got the 3 different formulas you can deal with. I would tell you on your worksheet today, I didn't make you decode anything, you have to break anything down. Everything is written out for you. So it's pretty straightforward today. Do you have any questions?